G'day guys. I've been given this old TRX 250 which had major engine problems. The owner took it to the motorbike shop. They stripped it down, took it apart and said it wasn't really worth fixing. All the parts are here in the boxes. So we'll have a look at it, see what's wrong with it and try and figure out how much it's going to cost to fix. Oh, tiny little conrod. Ah, there we go. The cam chain drive has been chewed up. Possibly it's been skipping a tooth or something. Bearings seem okay. What else we got in there? Clutch pack. The cam chain is in one piece. That doesn't actually look too bad to me. Just that cam gear so far. I wonder why it did that in the first place. Right, I've done some research and found that apparently these gears are machined onto the shaft. To repair it you have to get a whole new crankshaft at a cost of around $300. So I could do that and probably spend a couple of days putting that together, because you know it's all in pieces here. It'll take me a while to figure it out, but since it's only a 250cc, it's not really that powerful, and I'd probably only make a couple of $100 on it if I sold it. So I'm not going to repair the engine. I've had another idea. I was talking to a friend the other day and he's picked up these hub motors. They came off an electric car project which wasn't very successful, and he got them for quite cheap. The motor has spun inside the housing and twisted this cable up, but we have tested them and they seem to work okay. So I'm going to make it into an electric quad bike using one of these hub motors on each wheel on the rear end, and I'll make a new rear end for it because I don't need that diff. I got a message from bigbattery.com a while ago asking if I needed any batteries for any future projects. So I got back to them and they're happy to send a 72 volt Falcon battery. It should be perfect for this, I think. I should be able to squeeze it in there just. These are quite heavy though. They must be possibly 18 kilo each. That'd be probably 8 kilo maybe. So it is going to be slightly heavier than with the engine, but it should be slightly more powerful as well, because these are only 11.6 kilowatt and these motors are 7.5 each times 2, so yeah, it might just have slightly more power than the petrol engine. And the hub motors actually have regenerative braking. When you're slowing down, instead of putting the brakes on, you can just let the hub motors slow you down and it's charging the battery at the same time. We'll strip it down, get all these plastics off, take off anything I don't need like the exhaust and that oil cooler there, and we'll give it a good water blast. Just try and reduce the weight as much as I can. Right, I've ripped off all the things I don't need, so that's reduced the weight by another few kilos. I'll leave these front brakes on, and also there is a little micro switch here. You can hear that noise. I will rig that up to the controller so that when I pull it on slightly, that will trigger the regenerative braking on the rear. I think that should work okay. That's just an on-off switch. That's another 15 kilo lighter. It's all in pretty good condition actually. Those bearings are pretty good. Alright, now I've got to build a new axle for this. I'll weld that to there and then weld a flange to that to mate up to this one. On this one I'll have to weld the hub motor mount, which will just be a length of this, welded sort of probably below this one. I have to put it below because there's a nut that goes on there which clamps it on to this piece. I also need to make the axle the right width because I want it to be the same width as the front wheels, because I might end up putting tracks on it, like just use a tractor tire or something and put it over front and rear wheels, because these are independently operated, these motors, so I might be able to make it into a tracked vehicle. Because the hub motor is quite big, it's not going to fit inside the four-wheeler rim, so I'm going to have to use these rims with 14-inch tyres. I'll just run them really low pressure and they should be good. So they'll go on the ends there, but then the nut has to have room to move. I could either raise this piece slightly and put like a spacer in there and weld it up. I think what I'll do though is cut a little section out of there, because this is 5mm wall. It's going to be plenty strong enough for this little ATV. So yeah, just cut a section there so that I can turn the nut and tighten it up. That's pretty well lined up with that face there, both ends of the housing, so we know everything's going to be square then, because it's sitting flush against this edge and that edge, so everything's nice and square. Right, I'm going to weld these on here, and I'll just put that in there as a spacer and take it out once it's welded. Once they're welded on, I'll just cut a slit down the middle, then I can clamp it together. These two bolts compress the sleeve, these two lock into the keyway, and this top nut clamps it that way. Oh, how's that? That offcut fits perfectly. That never happens. So I've measured everything up. Everything's level and square to the frame. Measured across from the centre of the swing arm bush to there, to that corner. And that all lines up nicely. Put a square up to that top tube, so I think that's pretty central. And also line it up this way as well, just by eye, to make sure the rear axle is in line with the top of the bushings, and that is looking pretty good, I think. Right, that's the axle done. It's all ready to attach the hub motors, but first of all I'll go around and get rid of all this rust. Put a rust colour on it and paint it. Right, now I've got to try and figure out how to squeeze that controller in there. As it is, it's really too wide to get in there. The battery hasn't arrived yet, but I'll put this box in there just to show the size of it. I think what I'll do is cut this relay off the side there. I've made up this cardboard template, the width of the two controllers, and it's a bit of a tight squeeze, but it does get in there. I think that's probably the best way to do it. It doesn't stick out the edge there, and it'll come up to probably about there. I'll just have to make up some sort of frame so it's sitting above the battery there. Thermal grease down there. That's how it's going to go, and there'll be about a centimetre clearance between the top of the battery and the fans, so there should be a bit of airflow in there. Not sure if I'll need the fans yet. There might be enough airflow coming through the top across this plate, so I might end up taking those fans off anyway. We'll see how it goes. It looks like there used to be a fuse here and this wire has been put across. I don't have one of those fuses, so I'll take that off and just put a 250 amp breaker there. Somewhere down here. A fan of the channel actually sent me these a kit of these cleaners. I think it's like fiberglass bristles. Cleans up electrical connectors quite nicely. There's a wire brush one as well. I want the connectors to be as clean as possible. That goes to the battery, through the breaker, through the relay, and to the controllers. And those controllers doubled up by this bar here. Right, this wiring is a bit messed up because the shaft has spun inside the housing at some stage with the previous owner. It's ripped up the sheathing on the cable, so I'll just put this stuff over it to give it a bit more strength. Everything else is pretty much sealed, but just where the wires go, and I think could possibly get water in there if you go through a puddle or something. Try and seal that up with silicone. This hub motor seems to make a bit of noise inside the hub, so I don't know what's going on there. Hopefully that's nothing major. Possibly a little bit of rust on the rotor maybe. Guess we'll have to wait and see how it performs. Might end up having to pull that apart and fix it. I've connected the power up to this little 18 volt battery, and I noticed this resistor was heating up quite a lot and the relay wasn't closing, so I've disconnected that diode and she's away now. Must be a faulty diode, so I'll replace that. When the relay releases, if it doesn't have a flyback diode, it generates like a voltage spike just from the coil of the relay. So you can see it with these LEDs. You'll see them light up when I release the power, and that means that it's creating like a reverse voltage. See the LEDs lighting there? That's like a voltage spike, and we don't want it to damage the controller. You can see that the lights aren't lighting up anymore. So we know it's safe to connect to the controllers and it's not going to cause any damage. I'll see if I can get the computer talking to the controllers. Let's see what happens. The lights are flashing. They're flashing a code, I think because there's no power to the motors. Yeah, 1 and 3, that's low voltage, but I think it should still connect to the computer. Aha, there we go. There's quite a few settings we can change here. Startup delay, hall sensor type, 120 degree, control mode, torque, balance speed. We'll leave that on torque. Over voltage 136. Regeneration, there we go. So releasing throttle starts regen. That's good. So we can either have it by activating brake switch or just by releasing the throttle it automatically regenerates. You can adjust the regeneration current. Brake sensor starting point. I'll check the other controller and make sure all the settings are the same, and then we'll try and get these motors spinning. Right, I've rigged up 6 lead acid batteries and tested it's around about 72 volts to here on the motor side. Alright, that's contacting. And we have green lights there. That's what we want. Break it in. I've got it off the ground here, so the wheels are just freewheeling. Let's see how she goes. Oh well, that's promising. It's spinning the wheels, running on 6 dodgy lead acid batteries, so that means it should run fine on the 72 volt lithium battery. There's quite a bit of weight in those hubs. Most of the weight is actually at the rear end, so it's good to see that it can actually spin the tyres like that. Oh yeah. Oh man, that is so smooth. Oh yeah, the batteries have finally arrived from bigbattery.com. Okay, there's the charger. Ooh, let's have a look at the specs on that charger. 240 volt AC, input current 11 amps, output voltage 87.6. Oh, that's quality. That's the terminal blocks. They're nice and heavy. Brilliant. Mounting brackets. 80 volts. Nice. I like the lifting handles. That's a nice, easy way to lift them. They're not actually as heavy as I thought. Nice big heavy plugs as well. Should be well and truly up to the amperage required to run those motors. Look at the specs there. It is quite a sturdy battery, like it's all metal casing, so it's fairly solid. I have seen a heavy deep cycle battery get a crack in the bottom of it when someone put it on concrete, which had a little stone on the concrete, and because it was so heavy it just cracked through the base, and the battery had to be plastic welded. But these seem quite solid. They've got a metal surround, so they're really quite strong. Oh, that's not going anywhere. Alright, that's the battery connected. Just turn all the settings down while we're testing. 30%. Just with the one battery for starters. Motor top speed. Bring that down to 30% as well. I think it's pretty high already, but we'll just give it a top up. Yeah, it's going up quite quick. Must be just about full. Oh, there we go. That didn't take long. And now I think it's just topping up, equalising, fulling charge. So that's probably balancing the cells. So we'll just leave that to fill up for a while. But yeah, that was basically full anyway. The power for charging this is actually coming from my hydro turbine. So I'm not having to pay for power, it's just basically free power from the water. So cool. So quiet as well. Man, that's got some power. Even on 30%, that has got some impressive torque, man. All seems to be good. We'll take it for a wee blast down the road. Even climbing, that climbs really well, man. That battery's handling it pretty good. Amazing. That's so powerful, it's not funny. It's gone down only a couple of volts. Everything seems to be staying cool. I don't even know if we'll need those fans actually, because that's just staying cold as. It's a different sort of power than a gasoline engine. It's just instant torque. Even on 30% power with one battery, and I was only needing to use about half the throttle, it still had plenty of power, so that's quite cool. That's way better than I expected. And the battery's only come down a little bit. It's staying nice and cool. That's awesome. I'm happy with that. Very happy. Quite impressed with that, how quickly that gets off the mark, and top speed seems to be like far higher than any other four-wheeler I've ridden. Once it got moving, I had to bring the throttle right back to half because it just kept speeding up. So it's going to have quite a high top end, I think. Battery output is limited to 6 kilowatt, I believe, and the motors are 7.5 each, so that's why I have to keep the settings quite low with one battery. But they have sent two batteries. The only place I can really put that is on the front, so I'll make a base for it, get that wired in, and we'll wind the settings up a little bit. That will just be wired in parallel with the other one, so it's still the same voltage, 72 volts, but double the capacity and higher output as well. so quiet the animals don't even hear me. There's a couple of goats I just startled. There's one up there. That's a good hunting machine. Look at that. Another one went down there. That is extremely fast. Nothing is getting warm at all. That's awesome. So that's working well with 2 batteries. Carry on going. Oh my god. That is so quick. Right, we've had a bit of drama. One of the motors has actually stopped working. It was going along fine, doing about 60 kilometers an hour, and all of a sudden it started sort of cogging and slowing right down when I put that motor on this side controller. That runs perfectly, and when I put this motor on the other controller, that doesn't work. So I've narrowed it down to this motor, which is the one that had the cable twisted up before I got it. So I think there's something going on in there, maybe a short in one of the wires, or the sensors in there possibly. So it looks like I'll have to strip that down. It's a shame because it was going absolutely perfectly, then all of a sudden it wasn't. There's quite a bit of corrosion on those bolts. I think these motors have been sitting around for a few years.
That one should hold it.
Yep, are you ready to catch it?
I think if I...
Yep. Nice one. One of the wires has come off that hall sensor there, because as you can see in there, the previous owner had spun the shaft in his housing, and that has twisted up these wires really tight. So we think that's sort of pulled on this one, and that's pulled it right off the hall sensor. So that's one of the problems we've found. There's another set of hall sensors on the other side, so we're going to try and get that whole lot off and see if we can fix both sides so that we've got a spare set to play with if we need to. It's coming now. That makes it easier. So, oh, it's heat shrink there. Okay. Just a big lump of solder, is it?
It's done. That wouldn't be very good insulation just there, would it?
No. Also, like, look how that's kinked, that yellow one. Right, we've found a few problems with the stator, mainly with the hall sensors. one of the wires had come off this one, so that set isn't working. There's two sets here. The wire has come off that set, and the other set, one of them is faulty, so both sets of hall sensors aren't working. That's why the motor stopped running. I can't find any in New Zealand, and they're going to take about a month to arrive, so I've ordered those. We'll just have to wait till those arrive, pick those out and put the new ones in. And also we found that the cable was quite badly twisted up in here from the previous owner, so we've just cut the cable and pulled it out, and we'll get rid of the twisted parts so they don't short out, because that was bound up quite tightly. So we'll just trim that back to about there, feed that back through and connect it back to the windings. And also this bearing we found was a bit rumbly, so I'll replace that while we're on here. I was quite impressed with the power of those batteries. If you want to find out more about these batteries, I'll leave a link in the description below, and there's a 10% discount there as well.